Hello everyone, in this video lecture we shall solve this problem finding periods, which is the fourth problem of the string algorithm set. In this problem we are given a string of length n consisting of characters from small a to small z, and we are supposed to find all the periods of this string. A period of a string is a prefix that can be used to generate the whole string, right? So we take a prefix of the given string and we repeat it and concatenate all of them, and then we get the original string, the string that we have been given in the problem. Okay, so the input will be the target string of length n, and which consists of characters from small a to small z. Output will be the period lengths in increasing order, and the constraints of the problem are like n goes up to 10 to the power 6. So let's take an example to better understand it. So this is the input string abc. The periods will be, the first period will be abc, right? Because I am repeating abc once, twice, and a again. So the part which is missing is this, right? So my target string has been generated by repeating abc twice and using the first character of the period. Okay, another period will be of length 6 because I am using this prefix once, and second time I am just using the first character of the prefix. Okay, and obviously the entire string is also a period. Okay, so we have three periods, right? The first period is of length 3, the second period is of length 6, and the third period is of length 7, right? So that's the answer, that's how we print. So this is given here in the output. Okay, so let's see how we can solve this problem. Okay, so this I have written down the periods of this target string abc, which is the target string itself. Let's see the brute force method to solve this problem. So in the brute force method, the naive approach, what I am doing is I just brute force for all the possible ways. First I take the smallest prefix, which is of length 1, and then I check for the rest of the string if it can be created by concatenating the this prefix, which is a, right? But we can see that the second character is b, so the string of length 7, which will be formed from this prefix, that is a, will be a, right? Which is not same as this, right? So that's why we will go to the next prefix, which is ab, and from that prefix the string that we will get is ab, right? So which is not the target string. Then we take the next prefix, which is abc, and the string that we get by repeating this prefix is abc a, right? Which is indeed the target string that we need. So that's why this is a period. So the length of this period is 3. Okay, now we go to the next prefix, which is abca, right? And the string that we get by repeating abca is abca abc, right? Which is not the target string, so this is not a period. Then we move to the next prefix, which is abcab, and the target string that we get by repeating this is abcab, right? Which is not the required string. Then we move to the next prefix, which is abc, right? And the string that we get by repeating this prefix is abc a, right? So yes, this is the string that we have. Okay, so this is a period, and the length of this period is 6. Then we move to the next prefix, which is the string itself, which is indeed a period because I can repeat this string once and I get the original string. Okay, so the next period is of length 7. So that's how I do this. So what is the problem with this method is the time complexity. In this method, what I am doing, I'm taking a dummy string, let's say str, and I'm building prefixes. The first prefix is of length 1, 2, 3, 4 up to n, right? And for each such prefix I have to iterate over the entire string. So in the worst case, I am first generating this string, then I am iterating over all the rest of the characters, which is n minus 1, and the prefix is of length 1. Okay, then the prefix can go up to length n, and in that case I have to iterate just once, right? So the worst case complexity that we get in this case is big of n square. Because the first iteration is used to generate the prefix, and the nested loop will be used to check for to check if it is a period or not, right? So that's why the time complexity is big of n square. And we can see that the constraints are up to 10 to the power 6. So in that case, you see, if I have a, let's say, the string of length 10 to the power 6, then in that case the time complexity will be 10 to the power 6 into 10 to the power 6, which is 10 to the power 12. And we know that the number of iterations in 1 seconds done by the computer are 10 to the power 8, which will give me a time of 10 to the power 4, which is too bad, and it will give me TLE error, right? So this method is not going to work, so I have to optimize it. Let's see how I can optimize it. Okay, so the optimization lies, basically all I have to do, if somehow I convert this prefix in a more say compact way, like if I can pre-process this string in such a way that I do not have to do the work of generating the prefix, right? I do not have to generate this dummy string, right? So the solution to that problem is to use hashing, right? All I have to do is to hash the prefixes and then repeat the same process which I did in the previous case, that is to match the hash of the prefix with the rest of the string. Okay, so let's understand what is hashing, right? Hashing is the process of mapping keys and values into the hash table by using a hash function. That is, so we have some keys. Keys can be strings or some other data type. All we have to do is to use a hash function, and it will generate a corresponding key. Okay, and this is the value for that hash function, right? So I use a key, I generate its hash value, and then I assign some value to that key, right? So that's how the hash function is used. So let's see how this can be performed, particularly for strings, right? Okay, so what happens in strings is that we use a method called polynomial rolling hash. How do we generate the hash of a string which is of length n? Okay, for that what I am doing is I'm adding the first string, the first character, and multiplying the each character of a string with a prime number raised to the power I. I is the index, right? Initially the index is 0, so p raised to the power I is 0 is 1. That's why I am simply adding the first character in the equation. This basically in this equation the ASCII value of this character will be added. In the second term I have I as 1, so that's why I'm multiplying p, okay, and so on. P here is a prime number, and I am doing the entire equation modulo m, okay, because the purpose of p and m is that it will reduce the collisions that may happen in some cases. So collision is a case when two strings, two different keys or more than one keys, we can say, they share the same slot in the table. For instance, let me show you this diagram here. You see, if in some case, let's say key 1 and key 2, they point to same key, they generate the same key somehow, that is called a case of collision, because I have same hash value for two different keys, okay. In that case that will be a problem, and to reduce the collision I'm using p and I'm using m, okay. P is taken to be prime number, okay, and m has to be taken a very large number because I am doing it modulo this equation, right? So let's see how this can help us solve our problem, okay. Okay, so this is basically the probability of collision, right? How m can be chosen, why I have chosen m to be so large. This is because if I use the Birthday paradox paradigm to find out the probability of collision, then the probability depends upon this m, right? Upon this m, okay. The greater the m is, the lesser will be the probability of collision, okay. So this is how I get from this Birthday paradox paradigm, and that's why m has to be very large, because in that case only the probability will be small, right? Let's see how a hash table can help us solve our problem. So let's generate the hash table for this string, right? So hash table is just an array that I generate for this given string, and hash I, where hash I represents the hashed prefix of the string of length I plus 1, that is of string from 0 to I, okay. So this hash table has a length of n, which is also the length of the given string, right? This. So let's generate the hash table for this string, okay. So what is the equation to do so? The first the hash value of the first prefix, which is this, is simply the ASCII value of that character, which is 65, okay. So the ASCII value is 65. Then in the next case what I do is I multiply this value with the prime p that I have chosen and add the ASCII value of second character. And in the next case I use the hash of the previous prefix and multiply that hash with p and add the ASCII value of the character that I am standing on, right? That's how I generate the hash value. So this is a generalized equation. So to get the hash value of ith character, I use the hash value of I minus 1 characters and multiply it with p and then add the ASCII value of s, right, of that character on which I am standing, okay. So after I do this, the hash table that I get is this, okay. So let's see how okay, so suppose I want to find the hash value of some arbitrary range in between the strings, say from 2 to 4. How would I get that? All I have to do is take the hash value of the upper bound and subtract the hash value of the lower bound, while I also have to multiply this factor, which is nothing but p, which is the prime number that I had chosen before, raised to the power the length of this substring that I am taking, okay. That's all. This is because let's see why I am using this multiplier to get the hash value of this range. Okay, so you see, suppose I want to find the hash value of a single character, right? Let's say I want to find the hash value of this, right? So in that case, what I have to do is I have to take the hash value of ith character, which is this, and I have to subtract the hash value multiplied by p from of this prefix, right? So hash value of this prefix minus hash value of this prefix multiplied by p. So hash I, so the equation will become hash I minus hash I minus 1 into p, and this is equals to s of I, right? Which is nothing but the ASCII value of that character, that is a, right? So that's why, that is the reason I have to multiply this factor, okay, and I am doing it modulo m. Fine. So that's how I get the hash value of the range. So let's see the let's see how to solve the problem using the concept of hashing we have learned. Okay, so let's see how to solve this problem. So this is a target string, and m is a very large number, which is 10 to the power 9 plus 7, okay, and p is 31, which is a prime number, and I'm just using ll as long, okay. So first of all, I pre-process two tables, okay. So n is the length of the string that I'm passing, and I'm declaring an array power which is used for this purpose, right? And hash is another array which I am preparing and initializing it with 0, and I am preparing the power array which where power I stores the p raised to the power I, okay, that's all. And this loop basically constructs the hash table, which is using the equation which I explained here. Okay, so that's how I prepare the power and hash table. And in the next function, which is find periods, okay, so let's see how we can solve this problem, the main function. Okay, so the approach to solve this problem is simple. I take the hash of the prefixes one by one. The first prefix is of length 1. I take the hash of this, and then I try to match the hash of the prefix with the rest with the substrings of the rest of the string, right, that are of same length as the length of the prefix that I have chosen. Okay, so that's the approach. The first prefix that I choose is of length 1, and then I try to match the hash of the prefix with B C A B C A. Okay, then I take the prefix of length 2 and I try to check the hash of the prefix with the hash of the substrings that are there in the rest of the string, that is CA, BC and A. Then I take the prefix of length 3 and so on. If some prefix is a period, then the entire string will be generated, and I will print the length of that prefix, right? So let's see how this function is working. So I'm taking in the string, which is the target string. I calculate the length of the string, and then I run a for loop. In this for loop, I am the iterator I is basically choosing the ending index of the prefix that I have chosen, right? Initially I is 0, so I'm choosing the prefix of length 1, that is A. So initially the prefix that I'm choosing is A. Okay, then inside the for loop I use another index that is called run index. I initialize it with 0 and another boolean variable check. This boolean variable will be used for checking if the prefix that I have chosen is a period or not. Okay, I'll show you how it will work. So the run index is initialized to 0. This run index is basically used for matching the prefix with the rest of the string. And here in this while loop, I'm running up until the run index reaches the end of the target string, and this alien stores the length of the prefix which I have to match, right? And initially I is 0, the length will be 1, then I will become 1, I will go here and the length will become 2, then it will become 3, and after that the length will become 4. But at a certain point, for instance when I reach the index 4, in that case this length the length cannot be taken as I plus 1, because I cannot match the prefix of length 5 with the prefix of length 2, right? So in that case the prefix that I have to take must be of length 2. Okay, so that's why I'm using this function. And once I get the length of the prefix that I have to match with the remaining string, then I use this function get hash. This function gives me the hash value hash value of the range L to R, and that's what I'm doing here. I'm checking the hash value from the starting of the prefix. Here the prefix is of length alien, and that's what this function is doing, starting from the first index up until alien -1, which is the hash it represents the hash value of the prefix with the hash value of the run index of the string, which starts from the run index and which is of the same length as the length of the prefix, right? So that's what this check is doing. If this does not match, then this becomes false, and it represents that the prefix that I am considering is not a period. Okay, Otherwise I update the run index to the next substring of length len. Okay, and after I get out of this loop, I check if I have matched all the substrings with the prefix, with the hash of the prefix. If it is the case, then I plus 1 is indeed a period, and I print it. Okay, so that's how I am performing my task in this function, right? Notice that in this get hash function I am using the equation that I have explained here, right? This equation is used here, and this this is used for avoiding the negative values of the hash. If it is negative, then I advance it by m. Okay, so if you can't understand this, then you have to go to learn the basic modular arithmetic. You can learn it from the website CP algorithms. Okay, so let's discuss the time and space complexity of this solution, right? In this solution I am pre-processing two arrays, and that is taking big of n time, and while in this function I am running this loop, it is taking big of n, and inside this I am running this while loop. This is taking big log of n time complexity. Okay, okay, so let's understand the time and space complexity of this problem. So see, in this function I'm pre-processing two arrays of length n, so that's why the time complexity will be big of n. Okay, and here I'm running a loop up to n, so the time complexity will be big of n. While in this while loop, in the nested while loop, once I have chosen some len, once I have some I plus 1, that is the length of the prefix, I have to take the jumps of the same size, right? So in the first case the jumps will be of size 1, so I inside the while loop I go to b c a b c a. In the next iteration I will go to the jumps of size 2, b c a b c a. In the third case I will go to b c a b c a, and so on. So these are the harmonic jumps, and we know the time complexity for that is log of n. Okay, so the overall time complexity of this function is big of n log n. Fine, and this is big of n, so the overall time complexity becomes n log n. Okay, so this will work fine for the constraints given, that is 10 to the power 6, and the space complexity is also linear because I'm using arrays here of length n, right? So that is how I solve this problem. Let me show you the implementation. So this is the implementation in C++. This is the get hash function, and here I am preparing the power and hash table, and this is the main logic of the problem. Let's see the implementation in Java. Okay, so this implementation is in Java language, and let's see the same in Python. So this is how I do this in Python language, and that's all from my side. If you have some questions, then make sure to post it in the comments. Okay, so I have attached the code in the description, so make sure to check it out, and thank you so much for watching my video. Bye bye.